So today we are going to solve this fourth problem, that is knapsack one. The problem statement is that there are n items numbered 1 to n. For each I belonging to 1 to n items, I has a weight of wi and value of vi. Taro has decided to choose some of the n items and carry them home in a knapsack. The capacity of the knapsack is w, which means that the sum of the weight of the item taken must be at most w. Find the maximum possible sum of the values of item that tarot takes home. Okay, so we are given n items and each of them have some weight and some value. I need to maximize my weight, my values by choosing weight such that my total weight should be less than or equal to W. Okay, let's directly take the input now from the users, Cn and W. Now vector in nums and vector in, or let us call it as weight and value for n I equal to 0, I less than n, I plus plus. We are going to take the weight I and value I from the user. Yes, first and W, then W1, V1, W2. So we are handling the input case correctly. Now I need to return the cost. Let us first initialize it by some W variable, and then I should just print it out on the terminal screen. So the basic approach that I would think of is that I could try all possible combinations. That is, I can check all the subset for my answers. So this becomes a recursive solution. So I need to make a recursion solution for that. So what should be the state for it? So at each index, I would be having two options. Either I could choose it or I could skip it in my subset. Like either I can include it or I could not include it in my current subset. So it is for sure that I would require an index state, and with it, I can see that there is a constraint on weight also. So I need to accumulate the weight at every index. So I would require my current weight with it. So these two are my states. Then I would just pass these by reference and int w and n. Now what? Now I need to decide the base case. So my base case is going to be my base case could be either less than 0 or greater than or equal to n. For my convenience, I am choosing I equal to n. If my index reaches, like it crosses the boundary, or the it crosses the total number of weights, then I should simply return 0 because there is no cost that it can return now. Yes. Now I have two options. Either I could not include the current index, so my value will become, if I'm not including, then nothing will add to my value, current value. So I would just call it further. With the same weight, no changes in the weight because I have not included it, W and N. Now, what if I include? If I include, then my weight, then I would be required. to add this weight of I would be required to add the value of my current index because I am including it in my subset, and then I would further call the function with the weight now increase nums value w and n. As I have included the weight, so I have just increased it. But I need to check the condition that my current plus weight I should be less than w. Then only I could add it. Like this is obvious. This is obvious. Like I will explain. And I could initialize it with the minimum value. And why I have done this? Because I would be required B in my next step. That is, I would be returning the maximum value of A comma B. So if I would have defined B in this if condition, then I won't be able to call it outside this. It would show us an error. That's why I first defined it outside this if condition. And I have initialized it with B as minimum value so that when we are going to choose the maximum between these, it doesn't cause any error, any miscalculation. Now we will just replace this dummy value with this helper function 0, 0. Both are initially my index 0, my weight, current weight is 0, and then I will call my weight and then value w and then now we should check with our test case here. Uh, it is giving us 80, which is wrong. It's a mistake. Like it can be less than or equal to W. So it just missed that case. Yes. Hmm. We should also handle this case also. Like my answer can go out of the 32-bit integer. So I will just choose n, select this n, and I would replace all my n with n. Yes, it was already there. And now where I should replace here, and it should also be int. Okay, now it would be giving us the correct answer. But what I need to do now is, right now its time complexity is 2 to the power n. But I could improve it by memoizing it. So without wasting any time, I'm going to declare my vector, which is going to store the pre-computed answers. And what should I write here? W plus 1 will work, and all should be initialized with minus 1. And dp, I will call dp here, control C, here, pass it by reference, and now here I should also call dp, and here also, uh, expected. Acha. Okay. Hmm. Now, first I need to check this that if my I comma current is not equal to -1, then return dpi comma current, right? And now I would just assign this here. Let us check that is it still giving us the same answer. Let us try with this now. G plus plus question 4 A least. Hmm. It is giving us the correct answer with this, but why is it failing? Okay, I have initialized it with L. Hmm. Now I think it should give us the correct output. Let's try and let's hope for the best. What happened now? What is this? Copy and just paste. Yes, now it is giving the correct answer. So now let us just submit our code directly. So yes, it is working properly, but the memory that it is using right now is too large. I could reduce it for like I can reduce it how? If I convert my answer to tabulation form. Can I do it? Yes, definitely I can do it. I would comment out this. Now, what is the how can we convert our answer to tabulation? So first of all, copy paste our base case. If I is equal to n, then return 0. If I is equal to n, matlab whenever it is greater than n, then my answer should be 0. So for so instead of this, I could initialize it by 0 here only. Then my base case is handled. Now, now I need to do a bottom-up approach. So I would see memoization is just the opposite of the tabulation. So I would just reverse my indexes. So initially my I was going from 0 to n. Now it would be going from and I equal to n minus 1 or I equal to n to I greater than equal to 0, I minus minus. and my current would be going from what was it going from? 0 to W. Now it would be going from W to 0. I would do that later on, or should I do it right now only? I would replace it by Ln. Here also Ln. Yes. Otherwise, it might have given us the problem. And now just copy this recursive part and paste it here. P of I plus 1 and current dp of I plus 1 current, and I should not return it right now. Now my cost become dp of 0, and I should just replace with this. Now let us hope that it should work. Let us try this on our first test case. It is giving some kind of error. Okay, so I'm not able to think of the tabulation form. I guess I will do it later on. For now, we have done the memorization. That's it for now.